Okay, so welcome everyone to this month's installment of the ReproNim monthly webinar. Today we're cycling through our various projects to our training core and taking the opportunity to use this session to introduce you, our listeners, to the How Would ReproNim Do That series of documents. So we're going to use this opportunity. I'm going to give some overview words. Dave Kennedy, Herholz will talk a little bit about one of the examples that he's worked with, and then JB Poline will put it back into the context of our overall training mission. The grant that funds this information is shown here. And so the overview of of today's session is going to be the repro why of why do we need these how would documents. Per will give us the repro example using an Enigma container and working through the containerizing a workflow example. And then JB will come back with his repro connections to the training materials. Next slide. So as most of us have talked about before, but it's good to reiterate every once in a while, ReproNim's mission is to improve the reproducibility of neuroimaging science and extend the value of our national investment in neuroimaging research while making the process easier and more efficient for investigators. ReproNim has developed a lot of tools that support software and data discovery, that implement standardized description of data results workflows, that develops execution options that facilitate operation across all computational environments and provides education and training to the community. In addition to these tools, ReproNim has come up with some organizational stratifications for trying to streamline the reproducibility process into individualized components that are each themselves a little less hard and can be adopted individually, thereby contributing to sort of an incremental ability for investigators to slowly increase their overall reproducibility of their research efforts. And this is something we've referred to as the 5 steps. Next slide. That's fine. You anticipated that the 5 steps. Yeah, so again, we're not going to dwell on the details of these 5 steps today, but again, there's lots of things we do in our normal workflows, starting from study design through data collection, through data processing, through the statistics, through the publication, where the elements of versioning of materials, of standardizing representations of materials, of being able to share and publish materials, and to be able to do things in a way that other people can access the data and other people can access the exact same analyses that we've done. So there's lots of steps along the way that very often we tend to do in ways that don't support reproducibility, and lots of those can be replaced with ways that can support reproducibility. And as I mentioned, ReproNim has developed lots of tools. So if you hit enter one more time, one will see that there's a bunch of tools that ReproNim has developed to help in a lot of these different areas. So fine, a bunch of steps and concepts and a bunch of tools by themselves don't really make anyone else very reproducible. We need to also train and teach the workforce to use these and do that in ways that make sense to people, so they can see, oh, this is how I used to do it. This is how I can do it, and I'm better off for doing that. Next slide. So that's really the impetus behind the How Would ReproNim Do That series of documents, to really put a real world spin on the tools and concepts so that we can discuss these things in a way that the user can see the relationships between what we're encouraging people to do and what they would have done, and sort of what this costs them to do, and hopefully make sure that that cost is worth the effort. So this How Would ReproNim Do That has a bunch of volumes. Each of these volumes tries to take a bite-sized chunk of analysis and provide a worked example and enough rationale and pointers so that the reader can emulate that example in their own actual context. And it's worthwhile to point out that many of these have accompanying Python notebooks or containers so that you can actually do them along yourself, even if you don't have all the software installed at home. Oops, next slide. So when fully fleshed out, each ReproNim How Would volume should have these basic building blocks: a nice succinct problem definition statement, an explanation of the theoretical way that ReproNim would like you to think about the problem, and then the in practice gory details of how you actually execute the theoretical position. These also, as I foreshadowed, include an assessment of what did this cost me? What do I have to do that is different than the usual way or the way you might have done it before, and an assessment of what I have gained by doing this in the ReproNim way. And if you hit the space bar one more time, again, it's to remind us that we, as developers of this scheme, need to make sure that the cost that it's costing investigators is well worth the value that's being gained by doing that. And so that's what we need to keep that in mind, and we need to urge our users to help us understand that and make sure that we're meeting those objectives. Next slide. So that's enough introductory words. Where is it? Well, if you go to how-wood.repronim.org, you will find this document. It's built in a very similar way to the DataLad handbook in terms of generating its materials. And thanks to Adina and Jarek and the DataLad team for helping us learn to format documents this way. So there's an introductory section, and then there's go ahead. And then there's a bunch of volumes that exist already. So there's examples where we take a local container and do running sort of local and sharing, publishing a local container analysis, publishing data sets, marking up the semantic markup of software, managing local results, exporting behavioral data that you might have in REDCap, sort of in the marked up way, going from DICOM data into a nice standard vids and DataLad representations and containerizations of workflow. So it's also important, don't jump yet, okay. It's also important to note that all of these are still a work in progress, and some of these are workier than others. And in fact, even some of the red ones, may only just be released recently or not yet released. So this is a team and a community effort. We have these documents out there. They're built in GitHub. So if you have a comment, if you've noticed an error, if you'd like to see additional content, we encourage folks to file an issue at GitHub, and that's linked out from the document. So without further ado, I will turn the table over to Per to give us a little walkthrough and example, the Enigma container for SOQL analysis.
Yep, thanks a lot, Dave, for leading into this. So as mentioned before, I would like to go briefly through one of the volumes I was involved working in, and it's the how ReproNim containerize a workflow example, where basically our idea and goal is how to, sorry, let me get my pointer here. If we have our workflow, how we can combine that with container technologies and hopefully version control to create something we as the ReproNim folks and you as well as users will definitely love. As Dave mentioned, there's this great website with all the volumes hosted on, including this one we're going to go through now. And the real thing is already available there. And if we go there, should roughly look like that for you, with all these sections outlined by Dave in there, the problem statement, the solutions, theory, and practice. And as you can see, it's kind of long, but we really made sure to go through all of the necessary details with code examples and how to pack an existing workflow into the container and make sure it's usable anywhere else. So, and what I do here now is a bit of like a graphic representation and like a shorter walkthrough because we don't have the time, unfortunately, to go through all of its details. And the problem statement here is that we all, every researcher, depending if you're a postdoc or a PhD student or research scientist, we are right now and since a long time in the reproducibility wars. So just imagine you are part of a tremendously large research project that has collaborators over the world, and you are responsible for creating a comprehensive neuroimaging data analysis workflow. And after a very long development time, maybe several months or even years, your pipeline is working robustly, giving nice results, and it's ready to be shared with hundreds of collaborators all around the world. You might send that workflow via email or some other repository, and not long after you share your script, you'll receive hundreds, yes, hundreds, from all of your collaborators around the world, responses stating that your pipeline isn't working and won't even start running. So what happened here? Basically the following thing. Your pipeline is saying, you get an error, you get an error, everyone is getting an error because nothing works, it won't even start, you can't even get it to run the tiniest bit. Whereas you say, it works on my machine. I guess every one of us heard that sentence at least once in our scientific life. And the problem here basically is that each and every single project, no matter if it's applied research or a tool workflow, which we focus on here, and the development depends on a complex software environment. And this contains the operating system, so Unix-based ones such as Linux or Mac, or Windows if you like, the drivers you're running, and other dependencies such as Python, R, MATLAB, other libraries you might use. And just by sharing your code or using a repository, this might not be enough to ensure that these things are working in order. And spoiler, we know by now that it's not enough due to the aforementioned reason, that is the high complex software environment. And in the unlikely event that your workflow will run, other things from the dark side of unreproducible research can appear. And we all know the very nasty headlines, fMRI is not reproducible at all, nothing really matters, why are we doing this, all the results are not reproducible, we basically learned nothing. And there's actually more and more research coming out investigating these things in a more precise way. It's a nice example from Tristan Clauser and colleagues from 2015, where they compared different pipelines for estimating cortical thickness. And they compared different pipelines on the same operating system, the same version, or the same pipeline, a different operating systems and version. As you can see, changing the tiniest bit of your computing setup and environment will change the results. But that's something we need to address. And the question here is, are we all doomed to live in an unreproducible world, forced to painfully adapt and check every workflow we find and don't want to use? Maybe, and some aspects we unfortunately do, but we can also learn the ways of ReproNim and how it would containerize a workflow. And even though you might be new to all of this, the whole ReproNim concept, one thing you should already know is that this isn't reproducible amateur hour. This is ReproNim and this. Every little detail, nothing else matters. And if you want to provide a workflow for artists and you intend so, you have to go full ReproNim. That means everything you do needs to be under version control, needs to be fair, and needs to be reproducible. And if this all sounds like rocket science or a fairy to you, just don't worry. ReproNim's got you covered through this volume and a bunch of tools that were created within ReproNim. Important things you must remember before we advance to the next section is that every workflow depends on a complex and computing environment, and it's just not easily shareable. Everything you do needs to be under version control, fair, and reproducible. We just can't stress that one enough. And ReproNim obviously is the path to the light side of reproducible workflows and research. So the goal we're having here, really, just to formalize it once more again, is that instead of only working on your machine, your workflow can run and be made fully reproducible everywhere. This is our goal. And how do we get there? By learning how to use virtualization technologies such as containers and integrate them with version control. So this is really where we start going into details here. You learned from your mistakes, and luckily for you, there's the ReproNim Council and you sought help for them, and they accepted you as a reproducibility padawan. And in order to learn the ways of ReproNim, you must engage and master the 3 steps of containerizing a workflow, where the first step is place your workflow under version control. The second step, place your workflow inside a container that is transferable and shippable and shareable. And last step would be connect the dots and integrate further resources, because you don't have to stop there and you shouldn't. And within this, we're really going to focus on the second step, that is placing your workflow in a container. So we talk a bit more about these aspects than the others. So the software you need for this to accomplish our goal basically is version control, such as Git, containerization technology, such as Singularity or Docker, and obviously data lab. because you need data lab. Accounts you need for that could be a GitHub or a GitLab, and having also an account at Docker or Singularity Hub. And information you need that is important here is that all of these tools and accounts are free. There are pro accounts, that's possible, and it's nice to have them, but you won't necessarily need them. The development of your workflow can happen in a private or public repository. You, of course, know what we prefer. And all of these things work best on Unix-based operating systems. However, Windows is somewhat supported with limited capabilities. And here the chain of commands would basically be Linux, obviously the best, followed by macOS, believe it or not, and then Windows. So talking about the first step, placing a workflow under version control. Integrating or applying version control to your workflow really helps you getting serious with your code and development, because you will be able to track changes in your code base, revert mistakes, and find problems in your code. And it's also just amazing for collaboration development of your workflow and any other tool you might want to create. If you don't have Git applied or any other version control to your workflow, essentially it's not a good idea, because you have no idea what changed when, why, and how. It's very cumbersome and tough to fix breaks once they occur. Errors are hard to repair, and usually you're down to isolated work, and your development might be subject to stagnation here, which is also not very nice. And great examples for workflows that are placed under version control in public repositories that are also version controlled is the CPAC workflow that is also a supported project in collaboration with ReproNim, and the very, of course, famous fMRI prep. So now talking about step 2, that is placing workflow in a container. Even if you have these things, that's already great. You've done amazingly well so far, but it's just not the end. Just rashly assuming that this is enough, as talked before, is a very bad idea, because it won't be enough, because you will drastically evaluate installation processes and operating system binary dependencies that come with your workflow. And the idea is here, as Dave mentioned it in the introduction slides, we have to apply some sort of virtualization or environment encapsulation, where we try to make sure that all the things we need for our workflow to run as we intend to, and runs reproducible and can be shipped and whatnot, we have to get all these aspects together and encapsulate them in some sort of object that we then can share. And here's just a visualization of different kinds of virtualization that or isolations you can apply and look for, going from a bare metal to isolation in depth across various layers. And if we talk about containerizing the workflow, we will mostly talk about these layers here, going from Python environments to containers. Just to get you a brief overview and idea, just in case you're not super familiar with container technologies, what they are is that, or the idea is that you have some sort of infrastructure. Could be a local machine, could be your HPC, could be the cloud, and within there you have your operating system, and then you have some sort of engine. Here it's your Docker engine, could be a different one. And the idea is that these things, you share your host system's kernel with the containers. Therefore, it's called the kernel level virtualization. And each container gets its own isolated user space, as you can see here. And only the binaries and libraries are created from scratch. On top of that, an application, for example, your workflow. And thus, containers tend to be very lightweight and fast to start up if you do it the right way. And because we're always referring to Docker and Singularity, to give you a brief idea what's the difference. So Docker has one problem. It can easily escalate privileges on your machine or other machines, because effectively you need to attribute this root on the host system to make the mode of the functionality, install it, and run it. And of course, this is usually not supported by any administrators on any HPC, because you can count the seconds after you make this available, your system will go down because someone will do something horrible. And this is where Singularity comes in, basically, because it's a container solution created for scientific and applicational workloads that is supported by existing and traditional HPC resources. And the reason why is that a user inside a Singularity container is the same users outside the container. So you don't need those privileges and you don't need to ask like them. And the cool thing is it can even run existing Docker containers. So if you work at home for you at your local computer and you can have Docker or Singularity, in the end, it doesn't really matter. You can choose. But as soon as you go to other machines and especially HPCs, Singularity is the way to go. And if you provide your workflow without any sort of container, your collaborators, people that want to use this workflow will have a very bad time because the workflow maybe can only be set up and run by trained persons only, which is not very sustainable. Or you also try to avoid that the machine the workflow is developed on breaks down, and with it the entire workflow, you just can't get it to run anymore. Or the classic, I said before, I have no idea why it doesn't work for you. It works on my machine, or you have those installation nightmares. I'm pretty sure that everyone here had these days where you try to install a certain software workflow for hours and hours, and it just does not run. And it's just very annoying. And you say not so nice things to your computer, maybe. And the cool thing is, if you pack your workflow inside some sort of container, you efficiently isolate your workflow and its dependencies. You can then ship it and even can support and track multiple versions. So these problems hopefully are not a thing anymore because everything you need in this case is the software for containers itself. So either Singularity or Docker or something comparable. And with that, you can just ship it. People have these kind of container technologies on their machine, and it can just use your workflow. But the question is, how are these containers actually created for specific workflows or projects, and how can different programs be installed, and how you can share locally created containers? And for this question, it really comes down to two essential parts. The first being a recipe that defines and creates the computing environment needed for your workflow, and hubs, platforms that allow the sharing of your computing environment and container. And here I just provided a recipe, an example one, the one we have in the how with ReproNim volume number 9 that I showed you before. And it's for a rather complex workflow though. Sure, but it's 152 lines of very specific syntax and comments related to container software. And you don't even need to use the first to predict or see that creating a fitting container, having seen that now, is indeed tremendously complicated. And you might wonder, isn't there more sufficient, faster, easier, and of course, more reproducible way of creating container recipes? And of course there is, because ReproNim got your back via a very amazing tool called NeuroDocker. And I'm gonna briefly show you the its GitHub repository. And the idea is that, so NeuroDocker is a container specifically intended to build recipes for the containers. And with a focus on neuroimaging, of course. And with NeuroDocker, it's fairly easy to create very complex recipes and thus computing environments. And you can see there's a lot of software. The most commonly used software is definitely supported by NeuroDocker. It's super easy to set up. I definitely recommend you check out the GitHub profile and the tutorials that come with it. And just to give you an idea how easy it is, if you wanna have ants as a software inside a Debian 9 operating system, these lines, this is all you need to create that environment with NeuroDocker. That's pretty amazing. So applied to our example, if we use NeuroDocker, we can bring it down to 53 lines of simple commands and can even wrap that in a bash script to execute it. And then NeuroDocker will create this entire recipe. And the cool thing here is that it's very easy to create and adapt those recipes for both Docker and Singularity. It's reproducible because you can just rerun that script. And as said before, Docker supports a vast amount of software out there and even takes care of very specific installation instructions. And can even tell Docker, for example, if you want to have free server or you need free server in your workflow, you can tell it to just exclude all the data, the example data that comes with the classic free server installation, because you won't need it for your workflow most likely. And what you prevent is that you will have to manually write and change those recipes. You hopefully avoid messy commands in your recipe that just become very uneasy to entangle later on. And you can avoid unstable and error-prone builds from your recipes. Docker really takes care of all of these things. And for that, from Docker, we can go to a container with your computing environment. Then we place, or you place your workflow inside that container. So there's two options, to be honest here. You can place it inside your container and just ship it with your container, which of course is the best because it's also encapsulated. Or you have your workflow somewhere else and provide the computing environment independently and just run your workflow inside the environment. But it's of course it's maybe not the best idea in terms of full ReproNim. So we definitely opt for the first version. You put your workflow inside the container. And then you can upload that to either Docker or Singularity Hub. And these are the online container storage platforms that can be accessed via command line. So installing a complex workflow and just running it is as simple as one command line here. That's either Docker or Singularity pull, and then whatever you named your container. And then it will download your created computing environment with the workflow that is ready to run on your machine. And examples here are, again, the very amazing FMI prep workflow with today over 100,000 pulls from Docker Hub. Docker, of course, is also available on Docker Hub with over 10,000 pulls to this day. And on Singularity Hub, an example here, we have a lot of containers in the ReproNim organization you could also use ready to go. And the amazing part here is that you can share your containers and computing environments at a centralized place, and it's easy to download and upload. And you don't need to send them via mail or forget where they are. And another thing that you also see, just please write a bit here, is that each container comes with a tag version. You can have multiple versions of the same workflow and the same container, and you can differentiate between different versions, like legacy versions, current ones. That's all also built in here and possible. So now, how do we connect the dots and integrate further resources? Because we can always do more. Of course, it would be a given, we hope, that you also place your Docker script and the recipes under version control, so that everything is hosted in one repository, your workflow, your Docker script to create the recipes and the recipes themselves, because then everything is traceable. And an amazing opportunity is also presented while connecting your version control repository with those container storage hubs, because you can enable so-called automated builds and continuous integration, where automated builds basically work in the case where, for example, you change your workflow, you commit those changes, then your computing environment, your container will automatically rebuild with the new version of that workflow. Or you don't change your workflow, but you change the container. You change the new Docker script, you change the recipe, you commit those changes, and also your not changed workflow will be into the new version of the container. And you don't have to do that manually on your own machine and upload it. It's all there, traceable with logs and comments. And the other thing is continuous integration. So you can actually set up complex tests for your workflow to always ensure that if you change something, it doesn't change the output tremendously. And if it does, you can check out why is that the case. So you change your workflow or your recipe and container, and your output changes. So you can write specific tests to evaluate the influence of certain parameters on that, which is also great. because otherwise you will change that, you will commit it, people will use it, but then they get completely different results. And last but not least, of course, as for everything, use data-led when possible. And there's a nice data-led extension for containerized environments where you will see an example on the next slide. So to summarize a bit, place your workflow and your containers created through NeuroDocker under version control, build a connection with the hubs and version control repositories for automated builds and continuous integration testing, and use data-led containers where, comparable to any other data-led run command you would do, you can now actually link and add a specific container and does a workflow and a version of it to a data set, and then tell data-led, please run that container. This is my container name. Here's my data set, and this is the output I'm getting. So can even connect it further there. And as far as I know, maybe folks here can weigh in on that. This is the best we can do. This is what we want. Linking reproducible computing environments in containers in a reproducible way to data analysis through data-led. And just to make that sure once more, everything you do, place it on the version control, the workflow, the containers. If you want to create container recipes in an easy and reproducible way, make sure to use ReproNim's NeuroDocker and deploy and test your workflow via automated builds and continuous integration. Full disclaimer, it's of course not everything only light. There's always a bit of dark. There's pros and cons to everything, and the same accounts for containers. And if you want to do further into these things, I highly recommend an Open Science Room immersion session from this year's OHBM, where the topic was containers, Ticket to Valhalla or Ticket to the Inferno, and that credit goes to Dave. And as you can see, there are a bunch of ReproNim folks participating there with Sadra, Dave, and also myself. Where together with other people, we discuss a lot of pros and cons about containers and when and where, how to use them. And with that, I'm done with the quick walkthrough. Again, if you want to have the full thing with all the commands, really detailed, please go to the online resource where we host those things and all the volumes, and let us know if you have any questions, find bugs, and I'll want to help out. And with that, I give over to JB.
Thank you, Per, for the wonderful walk through the container and how would ReproNim do actually that specific container that you did for the Enigma project. I think that's the example that is actually in that volume. So my goal now is just to give you a little bit of a reconnecting to the other training material that ReproNim does. The how-to series is basically taking a use case and going through all the tools and concepts that we need and have developed and or are developed somewhere to go from A to Z where you want to do something specific and having with a specific goal in mind. But there are training materials that are more general, and how those two things connect is in a few minutes I will just try to give you a bit of a few thoughts on this. First of all, what did we develop in terms of material? Well, we have the actual courses and those are of various level and degree, so that's of interest as well. But also we are doing workshops. We have put those courses on a Moodle instance, and we have like an interesting trainer program where we have cohorts of future trainers that are spreading the reproducibility in your imaging world to the communities. And yes, so I also encourage people to apply to this trainer program next year. Next slide, please. So 5 modules for reproducibility for the courses are like first of all, the introduction of the motivation, the reproducibility basics. How do you use a terminal? Because all what Per was showing you is requires some basic things that you may not have or not everybody would have. Then how do we deal with data in general? So how do you make data findable, accessible, interpretable, reusable? I really like to emphasize the reusability aspect. I think that's one of the key words in the FAIR principles. Data processing, and that's very much linked also to what Per presented, and also some guidance on the basic guidance on statistics and how do you analyze your data. So those are our modules, and I will just give you a couple of examples of how those things are connecting to the how would ReproNim do series. Next slide, please. So there are different ways of thinking of it. First of all, those courses are not specific on, usually not specific on tools. They may use some tools, but they're not usually specific on tools developed by ReproNim often. So how would you use the how would ReproNim do series? And one of the things is you could take those documents and just try to follow line by line and read the text, follow line by line, and so on. The other possibilities, if you're thinking, okay, I'm a bit far from this, I will just go through all the courses first, and then try to do the how would ReproNim do containerized workflow, for instance. And you could spend a lot of time learning all the basics before you actually go to the place where you want to be creating something with a specific goal. So I would obviously advocate for a bit of back and forth aspects, where starting from the how-to document with if you have a matching goal, so a goal that is close to one of the how-to documents, is basically stopping where you feel like you are really uncomfortable, and then going to a bit more in the details, trying to find the material online. Obviously, the ReproNim material, if they are adequate for that, or elsewhere, and then go back and so on. So I think a good learning process would be having that goal in mind, but still taking the time to sort of dig a bit into the detail or the basics of some of the things that are presented in those documents that are often kind of a high level and designed for reusing tools directly. So that's and I will take a couple of examples that just to illustrate a bit what I'm saying. So next slide, please. So for instance, this is from the first how would ReproNim do thing, and it actually connects to a container. So in that document, you will see that okay, make directory work, CD work, Docker run, all those things. And then you think, okay, I can copy paste that command, or I can go into some document and actually the lesson 3 of the why and how to use containerized virtual machine in the processing course is one of the places where you can learn a bit more on those things, and then understand, okay, that line of command is first of all, you can look at the reproducible basics and learn about the terminal and and all those commands on the terminal, and then sort of go into that course that tells you a bit more on the container technology. So that's how those things can connect. Next slide, please. So another possibility, for instance, the volume 2 is publish a data set. So my first example was on volume 1. Now volume 2 is publish a data set. And that document is, this how-to document is actually fairly dense. It has and I don't think we have on the basic courses things that are directly related, but the data labs handbook in that instance would actually be your best friend. So what we're doing in those how-to documents is actually linked to the most appropriate courses sometimes. And I think we are still in developing. What Dave was saying is that we're still developing those documents. And what we are going to have to do, I think, in the future is making sure that we have links to more in-depth, more comprehensive material about something that is being really described in those documents. So the one example here is the data handbook. The other one is you may have to go back to the exact documentation of, for instance, the Biden IDM documentation that Dev Gator developed, and show and see exactly how to use those tools for that specific volume of publishing a data set. So this example was, yeah, that's fine. But the previous example was really like showing you that in some cases, our developed courses in ReproNim are not the best place, the best thing to go to. There are other external resources you should tag on. My last, oh yeah, those slides are not updated. I was updating my slides during the webinar. My last example is here on the red cap volume. So how would ReproNim make a red cap so the red cap data more fair and reproducible? And that's actually using the CSV to an IDM file converted in the Biden IDM tools. And this and for this specifically, I would say you really have to read first. If you haven't, if you have no notion of the semantic data representation, you really have to first read lesson 5 of the data and fair principle course to be able to use those things and understand what it is about and the rationale and how to do those things properly before going to that document. I think if you haven't that layer before, then I think it's a bit of a dangerous thing to play with those things without a little bit of an understanding of the broader context. So this is these are my 3 examples. I think I don't have any more examples. I hope I gave you a little of pointers of like how those things can connect, or sometimes don't, and what is next for us to do to make sure that we build those connections properly in the future. And this is it. I think Dave, you have one next webinar, so like a slide to tell people what is next on our agenda.
Yep. Thanks, JB and Per. So we'll open up for questions in just a moment. But while I'm here and while the slide is on, a reminder that next month our webinar will feature CoinStack, one of our ReproNim collaborative projects, and we'll have Eric Werner talking about the tool and an overview of CoinStack, and Theo Van Erp telling us a little bit about Enigma CoinStack. And then our goal is to have discussion with, about CoinStack and how it interoperates with ReproNim and the ReproNim mission. So that's just next week's advertisement. So I'll turn the floor open to questioning, discussioning. Now there's a small enough number that I trust you can manage your microphones yourself or type in the chat. And I may get things started just while we wait. Per, the NeuroDocker is cool and great and has lots of tools, but sometimes not all the tools that you might want are in NeuroDocker. And I think the volume 9 example does use a tool that doesn't come exactly from NeuroDocker. Can you say a little bit about using the NeuroDocker framework to also install non-pre-canned tools that NeuroDocker knows about?
Yeah, sure. So as Dave outlined, there's a lot of software available from NeuroDocker. Just has specific commands for it, and it's no problem to get these things rolling. But there, of course, are a lot of things out there, and integrating all of them in NeuroDocker might be a bit out of scope, but we can still use them. So NeuroDocker has functionality basically mapping NeuroDocker comments that translate to bash specific comments. So in the case we have here in the Enigma example, we have a software called Brain Visa that is tremendously important for the workflow developed. And this is not easily or by one command line installable via NeuroDocker, but we can still use NeuroDocker commands to, for example, download the Brain Visa software from an online repository and then install it by basically mimicking the steps you would do in your terminal, right? You can just mimic those things in a Docker script, and that would then translate into a build recipe, so that the build recipe would do the same steps you would do manually in your terminal. In the case in the example we provide, the case is that you have Brain Visa already as software on your machine, because this is the situation we build upon, right? You have a software locally running on your machine, but now you want to wrap it into a container and ship it. So the thing there is we just use NeuroDocker to copy the software we need from our local machine inside the container and then run it there. So there's different options. You can either have it already installed and you just copy it inside, or you include download and install directly in your container recipe.
Great, thanks. Any questions out there from listening land?
I have a question.
Okay, great.
Hi, thank you guys for your talk. This is really helpful. And I appreciated the comment about going back and forth between the how would documents and the tutorials, because that's exactly how it is working out, at least when I'm trying to figure these things out. I wonder if there's, I mean, a lot of these things, it seems like you have to start from the bottom and build up. And I'm wondering if there's a way to think about retrofitting some of these ReproNim tools into existing tools. And the example that I'm toying with right now, and I don't know enough about all the details to really figure it out, but like XNAT, for example, has a container service plugin. And so we pull these containers from Docker Hub or wherever, and then run them locally. And I'm trying to think of how you could wrap around a ReproNim wrapper to this container service plugin so that you could retrofit that scenario.
So can you just clarifying the goal? You would like to have the launching that container on some XNAT data more reproducible, because possibly there are changes in the XNAT database, or because you I mean, what's the, you know what?
Well, just
clarifying the user story somehow.
So I'm just thinking, if somebody's first exposure to a workflow is in XNAT and they don't quite, well, okay, I don't quite understand what all is being captured behind the scenes, but I want to make sure that it can all be forwarded to somebody who wants to ultimately reproduce that workflow elsewhere. How would I go about figuring out what I need to make sure is captured in that workflow to make it reproducible?
I see. I guess I don't know how. I mean, maybe if someone knows how XNAT interacts with containers, that's because basically you have the data in the XNAT database, right? And you're running a container that will see those data. So the container itself is kind of well captured, and you can ship that container, which has the workflow. The problem is how do you make sure that the person that wants to rerun that container will have access to exactly the same data? So it's more like or at least to the exact same shape of data if those data are different, because I'm pretty sure that the software that we run on those data will kind of expect a certain organization. So if it's in bits, or it's kind of easy, but if it's a specific organization, it might be more complex. So I think what you're asking is, how do I capture the exact data that I am feeding the container with, such that someone else could do it? So I think that in that case, that would be how do I? So I have, there's a possible answer. There is, I don't know where are things, and I think probably Safra, you would know more of that, but we know that there is an XNAT data crawler. So you could, I think you can extract from XNAT the state of the data, freeze those things in a data set. And then if you could just plug that container to the data set and coming back to pair presentation, you would have like those two things that are extremely well characterized. You know exactly what they are because they are hashes of what they are. So both the container and the data set, and then you have like something where you solidly that you can reproduce exactly the same thing. But it really depends on how that container interacts with the data, I think. I'm sure Satra and Per and others would have like more comprehensive answers.
So I'll make a quick comment. It's really about this impedance match that JB is talking about, which is you can put any workflow in a container, but if that workflow cannot talk to the data, it doesn't matter what container it is, it's not going to run. And so think of a simple scenario. XNAT can export bids, right? So you could potentially run fMRI prep or MRI QC on XNAT exported bids data set. But if you try to run fMRI prep or MRI QC directly on the XNAT database, it won't know what to do with it. And so that impedance match has to be done somewhere. So I'm assuming that future things will kind of go more towards query-driven thing. And this is exactly where we're trying to go with something like ReproLake, right? So if you had a ReproLake shim on top of your data set, you make a query on the ReproLake, you download the relevant pieces of data into a standard format like bids, run some pieces of operation on it, and now that becomes a more generic kind of container that could be run anywhere as long as there was this query interface that's consistent. But it really goes back to that query interface. With XNAT, you're looking at XNAT's API. With ReproLake, you're going to be looking at ReproLake's API. With other sources, so DataLad might be that intermediate API to start with that says, I can talk to XNAT, or I can talk to ReproLake, or I can talk to OpenNeural, and I can give you a format so you can create containers that need to understand bids as a workflow setting. So that really makes it a nice chain of operations and sufficient modularity to try and get something like this working. Otherwise, it really will be how you download data. Now, that's in the short term. In the long term, I think all of this is out the window as well, as the data sets get much, much, much larger. But that's a different problem we'll get to when we get there.
Thanks.
Thanks, Satra. Any other questions out there? Andy Worth asks in the chat, what do you think about DVC, data version control at dvc.org? JB, Per, Satra, Yarek. Hello, Andy.
Not to put down DataLad or something, but it would be an alternative.
Sure. I think part of this really is about where the data are and what scale you're talking about. That's what this boils down to. So you could take all of these are conceptually, I think, very similar systems, which is data is under version control. Something has to provide that version control, which means something has to provide the storage space for that version control. If you're only storing models, which are very lightweight, maybe a few megabytes or tens of megabytes, that's one thing. If you're storing something like the ABCD dataset or the Human Connectome project, you're talking of much larger scales of data. So doing version control on that is a very different scale of problem than doing version control on neural network models. So I think part of this is really about the scale of information rather than the conceptual mechanisms. On that front, DVC is yet another version control system.
But DVC mostly just uses Git and pointers to the data. So you could have the data in an AWS bucket or something. So you could have as large a thing as you want, and all you have in Git is the version and the pointer.
And that's what DataLad is doing as well.
And Yarek did post in the chat some pointer to something about DVC in the DataLad handbook, which if he's either going to speak out loud or the listener will have to go and read that on their own time. Just try DVC and report back on how you like it for your workflows. Smiley face. Okay. So yeah, so that's a conversation we can continue. We're near the end of our hour, and So I'd like to thank everyone for joining us. Those of you who joined us live, as always, these are also on the webinar YouTube page, so you can see this and all the other ones at your leisure. Thanks, and see you all next month.